We have already talked about the match statement in quite some detail, but now I'm going to sort of expand on what the match statement is by discussing the different ways of pattern matching. And for that, I'm going to make a separate module. Let's just call it PM for short, PM, like so. So this is something that I'm going to use out of my, oh wait, it should be inside SRC, I think. And we're going to use it outside of main using the mod PM like so, and it's going to be called pattern matching. So PM pattern matching, that's what we're going to call the function that's going to actually demo the whole thing. So here it is, here is the actual module. Now let's begin by first of all creating obviously the pattern matching function that we're going to use for the demo, and then I'll give you a few examples of just how powerful this whole pattern matching construct really is. So let's imagine that we want to print the number of, let's say the number of oranges that I have for a certain number. So let's say I can have anywhere from 0 to 12 oranges. So I'm going to do for x in 0 to 13, and here we're just going to do a simple print line. So let's print the number of oranges I actually have, and let's also print it in text. I have so many oranges. All right, now the value here is x, and here I'm going to use a function called how many of x. So how many is going to return a static string, which depends largely on whether it's 0 oranges. In this case, I want to say I have no oranges. If it's like 1 or 2, I want to say I have 1 or 2 oranges, and so on and so forth. So let's see how this goes. We're going to have a function called how many, which is just going to take an x and an i32, and it's going to return a static string. So a static str, like so. And here we're going to do some of that pattern matching. So we're going to match the value of x with a couple of patterns and return certain strings depending on what the pattern is. So for example, if I have no oranges, then we're going to return the word no. Okay, now obviously we're not going to be able to execute this particular chunk of code. Actually, let me make sure that I set the startup project correctly. If I try to run this, you'll see that there is a bit of a problem. We're covering the case where there is 0 oranges, but we're not covering all the other cases. Like if there is 1 orange, for example, it's uncertain what this function is even supposed to return. So in this case, we need some sort of catch-all condition. We need a catch-all condition which says a few. So maybe if it's not 0, then it's going to be a few. And as I run this, you'll see that for 0, I have no oranges, and for the other options, I have a few oranges. Now, if I want to cover 2 particular cases where I have 1 orange and where I have 2 oranges, the way I can do it is by using a vertical bar to list all the cases. So I either have 1 orange or vertical bar, I have 2 oranges. And in this case, I'm going to say 1 or 2, so I have 1 or 2 oranges in this case. Should learn how to spell. Okay, let's run this. Forgot a comma here. All right, we're good to go. So in the case of 0, I have no oranges. Whether I have 1 or 2 oranges, I have 1 or 2 oranges printed out, and we still have this catch-all case, the kind of don't care case, where I just have a few oranges. So the vertical bar essentially lets you list all the cases that you want to consider for the particular instance. So if I have 12 oranges, for example, I can say that I have a dozen oranges, and I can certainly print that out, and I have a few oranges all over the place. But for 12, it's a specific case, and I have a dozen oranges, because that's the case that was actually matched. The first case that gets matched gets returned, actually. That's how it typically works. Now, if I wanted to, let's suppose I want to have a special printout when I have between 9 and 11 oranges. So maybe I want to say I have lots of oranges. The way I can do it is by specifying a range. I can say 9 ... 11. Notice it's an inclusive range. I don't have to put a 12 here if I want 9 to 11 inclusive. So here we're going to say lots of oranges. So as I run this, And let's not forget to put commas in between the case match statements here. For 9, 10, and 11, you can see that we have a printout. I have lots of oranges. Now you can specialize this. For example, maybe I don't want a few all over the place. Maybe in the case where there is an even number of oranges, for example, I want to say that there are some instead of a few. So what I can do is, I don't care about the actual value, but I can say if the x value, so the value of oranges that we found, if the value, if the remainder of division by 2 is exactly 0, then I want to use sum instead. Okay, so how does this work? Well, as you can see now, above 2 oranges I have a few, but for the even cases, 4, 6, 8, I have some oranges. So essentially this if acts as another condition for the match. So if the if condition isn't satisfied, we don't execute this case. But if the if condition holds, then we do in fact execute this case. Now it's worth noting that you can also give this range a name if you want to use this range somewhere inside the processing of the particular case. Then you can give it a name. Like I can say that this range from 9 to 11 is called Z. And the way to do it is you say Z at 9 to 11, and then you can operate on Z as a range. Okay, so let's take a look at some of the other examples. Let's take a look at examples of tuples. So let's suppose I have points. So let's make a point. I'm just going to call it point, and it's going to be composed of 2 numbers. So the x and y coordinates, for example, I'm not going to make a struct, I'll just have a point as a tuple. Now what I can do is I can match on this tuple, match on the point. And what I can do is I can, for example, first of all, if the point is at exactly 0, 0, then this is the origin point. So I can match against 0, 0, and I can say if this matches, then I'll just print line that we're at the origin. Okay. So if it's not, but if one of the coordinates is 0, like for example the x is 0 or the y is 0, then we know that this point lies on a particular axis. So for example, if the point has an x coordinate of 0 and a y coordinate of some kind, then we can say that this point lies on the x-axis and y is equal to the value of y that we've just introduced as a variable here. So we're going to match point against this case. So if x is 0, then y will get initialized with the value of whatever y is, and we can actually print it out. And similarly for the x case, if in case y is equal to 0, we can write it like this, and we can say that in this case the point is somewhere on the y-axis, and x is equal to the value of x. There we go. And finally, the catch-all case where neither x nor y is equal to 0, we can just say x comma y, and we can print line the sort of the coordinates x and y like so. Okay, so let's try running this. Let's see what we get as the output. As soon as we fix all the bugs, obviously, because there should be no semicolon here. Okay. So at the moment the point is 3 and 4, and we print it out because neither of the elements are 0. If I set both of them to be 0, then we should be at the origin, and if I run this, then we get origin as the output. And if I set only one of the coordinates to be 0, then let's see what happens. It says you're on the x-axis and y is equal to 7. So that's how pattern matching works. Incidentally, if you don't care about some of the variables, like for example, you don't need this x altogether, because let's imagine that you're not using it at all. The x coordinate in this case is irrelevant. Let's just put a question mark in here. Then instead of writing the variable, you can write an underscore. This means I don't care what the variable is. It's kind of like the underscores we've been using up above when we want to indicate that we don't care about the value of the actual variable. And here, if I set it to for example, 3 and 7, then y will get initialized to the value of 7. However, there is not going to be a variable which gets the value of 3 because we don't really care about it. So in this case, we can run and we get just question mark 7. We're not using the x coordinate here. Okay, so just a few more things worth mentioning, and we'll also look at a case that we've also met. But before we jump into that, I just wanted to mention a couple of things. So first of all, it's possible to actually make these variables like x, for example, pass to you by reference, as opposed to just pass by value. In this case, you just put a ref in front, and then you're working with this as you would with a reference. It's also possible to do a ref mute. In this case, it becomes a mutable reference, and you can actually manipulate this value. I don't know why you'd want to do that, but in some cases, I guess it's nice to have a value where you can also change the result. So this is how you do it. You can declare it at any particular location. So another thing that I wanted to mention is something that we did when we looked at the colors. So let me jump back into our color example. Remember, we had an enum, and then we did this big pattern matching thing. So let me just copy that into our example, because I want to show you another thing that you can do. So jumping back, I'll just copy this over. So remember, when we were matching against a struct, which was part of an enum, we basically had to define the cyan, magenta, yellow, and black coordinates. The cyan, magenta, and yellow were underscores. Well, guess what? You can get rid of them altogether. And instead, what you can do is you can put a comma here, and you can put 2 dots. And the 2 dots indicate that we only care about this particular value, the black value, and we absolutely do not care about the other values. And that's what the 2 dots here signify. And if you run this, the end result is exactly the same. You still get black as the output, because we only care about the black value, and all the other values are ... And naturally, as you can imagine, you can pattern match against more complicated constructs. Like, for example, if you have a struct with an option in it, you can match against a struct, open round, then the field with the open round, and match it this way. So the pattern matching is infinitely deep, and it's very powerful in being able to match exactly the structures that you expect and get the variables out. Or if you don't care about the variable, then you put an underscore. If you're looking for a specific value of the variable, you just put that variable in there. So an extremely powerful technique that you should use a lot in your programs.